This is 7.3, problem 27 and 37. And problem 27 says that we have the line y is equal to the square root of 2, which is about 1.4. Square root of 2 would be along here. And y is equal to the secant of x tangent of x, which would be a graph that would look something like this. And we want it bounded by the y-axis, so it's this region here, revolved around that line. What I would do is graph this and put this as y is equal to tangent of x divided by cosine of x, which is what secant is. You're going to find out that this point right here crosses at pi over 4. That's because we're looking for the intersection of pi over 4 and secant of x, tangent of x. We're looking for where that would be equal to square root of 2. Tangent of pi over 4 happens to be 1, and secant of pi over 4 is 1 over the cosine of pi over 4, which is 1 over the square root of 2 over 2, and that will end up being square root of 2. And so our big radius here is this distance right here, whatever that would be, and that will be square root of 2 minus secant of x tangent of x. And little r, because we are bounding our axis of rotation, is 0. And so I'm not going to work out the numbers, but it would be pi always r of x squared minus little r of x squared dx. That's our basic formula. This would be from a to b. This would be from 0 to pi over 4. And it would be that square root of 2 minus secant of x tangent of x squared. So that is number 27. Number 37 says that we have the line, the y equals x squared, y equals 1, and this point, of course, is 1 comma 1. So this point of intersection here is 1 comma, or is at 1, x equals 1. This is so similar to this problem that they're almost the same thing. So I can understand if you're having trouble with this one, you'd have trouble with this one. The very first thing that we're going to do, let me get my book, I believe we revolve it around the line y is equal to 1. I had this all written out, but yeah, around the line y is equal to 1. So very similar to the last problem. We're revolving it around here. My big radius then, so this is for A, my big radius is this distance right here, and that would be 1 minus x squared, and my little radius is 0. And so this will go from 0 to 1 pi, we need the pi here, pi 1 minus x squared squared dx. The second one, it says that we want to revolve it around the line y is equal to 2. Well, now that's interesting because y is equal to 2 is up here. I didn't do that very well. Y is equal to 2. My big radius then is this distance. So for b, r of x is 2 minus x squared. And my little radius is this distance. It's technically 2 minus 1. I should have drawn this out so we could see it better, but if this was like this and we're revolving here, what we're doing is taking something that looks like that and something here that looks like that, and we are cutting out of the inside of that. That's not very good. We're cutting out the center part of it. So this has a hole through the center like that. It's like a washer is what it is. And so we have pi from 0 to 1, or 2 minus x squared minus 2 minus 1, of course, is 1 squared dx. And then for part C, what we're going to do now is switch this, and we're going to revolve this. Instead of around 2 axes above, we're going to go around this line. Right, let me erase that. And this is no longer a part of it. So what is my big radius? Well, my big radius is this distance here. And that would be 2 minus -1. And my little radius would be this distance from here to here. And that would be x squared minus -1, or x squared plus 1. And so this would end up being pi from 1 to 0, 3 squared minus x squared plus 1 squared dx. This one, if you were to try and figure out what the shape of that thing would be, what we've got right here, and I'll have to do this, so this is 1, 2, 3. We would have something like this, and then what's being cut out is this shape out of the center of it. So you would have a cylinder with kind of a lampshade type thing cut out of the center of it. So that is problem 27 and 37. And I'll post that and get a link for you. All right, so I'll get this posted for you.